Start recording. So yeah, welcome team. As I said, you can reach out to me anytime when you're stuck. We will figure out a time, get together, fix the issue so that you can get going, so that you're not stuck until the next week sessions. Okay. Um, so awesome. Let me share my screen and then we will first address the files upload thing, I think. So anybody want to share the screen and show that?
Let me share my screen. Maybe
Yeah.
just correct me. Okay. Are you able to see my screen?
Not yet. No, we are not able to see the screen.
No, it's not able to share.
Okay. Subbu or Shanmuga, anybody can share and show how to upload the files.
Yeah, I will share my screen.
Okay.
Okay. Will share screen.
Yeah. You're able to see your screen, Subbu.
Uh, Data fix. No.
Community. Sign in.
Just a minute. Somewhere, no, this account is different.
Oh, haven't
No, no, no. Data fix.
Mark.
Yeah, yeah,
Okay.
yeah. And plus.
Okay, Srini, here, if you
Yeah.
go to new,
New and go to create a notebook.
no, it's not notebook. So you need to go to catalog.
New and
No, import file, right?
Okay. You
So
can do
import, select the URL. So whatever URL we received,
no, not the notebook. It's
hmm,
talking about uploading the source files, JSON files, right?
yes, of course.
okay,
Yeah, that's true.
Yeah, yeah.
okay,
So you
okay.
go to catalog,
Mhm.
create table, and then here you can give the path
Okay, path.
in the
Give
files
some
or
name.
table
Mm,
slash whatever folder name you want to create.
just
Then,
DB.
yeah, this table.
And then come here, select upload. And
Yeah, you
uh,
can upload any file just.
so I have different files. You can select all of these files and open.
Mhm.
That's it. All files are uploaded.
Still loading here, waiting and
Oh,
tag.
that is big one. That's fine.
Yeah,
So basically now, if you see the path right at the below, slash file store slash table slash testdb slash genome tags.csv. That is the path you can refer to in your notebooks to access these files.
And what about this one? Create table with UI. This means we don't worry about
So
those.
when you click that, it will automatically create a notebook
Okay.
for you. And
Okay.
then it will generate some code to access this file. It's the same thing. Access this file, read and create that in the table.
Okay.
So it just creates a notebook for you to load this file into a database table.
So once you create it, now go to the create a note, a new notebook, and use where it is. Yeah, so use any of these, for example, so copy this one. So it is created. Okay, I'll go to, I will use first one. Letter, yes, Amazon.
Okay. So
Yeah.
does that answer your question?
Yeah. Thank you.
Okay. Yeah. All right. Yeah.
Okay.
Thanks, Subbu.
Yeah.
Yeah. So once you go to the notebook, you can just go dbfs, utils.filesystem.dbfs.ls, and then you give the path, you can see the files there. Okay. All right. So, yeah, last week, over the weekend, we tried doing the event hubs Spark streaming. We had some technical issue. We could not complete that. But you guys are good, right? Whatever we have discussed till then I will go ahead and continue from there. So it was just weird issue. I kind of checked that. We'll go through that again. Okay, but last time, if you see, we were not able to. I will come back. We will rerun the whole thing. But I just wanted to show you where we were stuck last time. We were stuck here to install this libraries, right? So when I do a install library and I went to Maven and then we search packages, Maven Central, and then we wanted to do this. What is this happening? Azure Event Hubs Spark, this thing, right? So if we go here, Azure, and then it is saying no results. But actually, if you do this, what is this here? Just take the whole name, Azure Events Hub Spark 212, and search for it. See, it is visible. So it was weird that it was, when I was searching only with part of it, it was not showing up. It was showing something else, reactive, this stuff, but it was not showing what we need, that library. So that was the issue. But when we put the entire thing, it came up. So this is what we needed, that library, Events Hub Spark 212, release 2322 to read that. Okay. But however, let's go back and start from the beginning, how we want to do the Azure Events Hub. Right. So last class we have done how to create Events Hub and display data, right? Remember, we did this one, custom data and how events are published in the Azure Events Hub.
Yes.
Yes.
Okay. So we go here. So what are all that is required to set up this thing? So we said we need to set up 4 things in the Azure Event Hub. First, we need to have a Microsoft Azure login credentials, right? Create an account, and then you have all of these services. So first thing we will create is a subscription. Okay. So we created this subscription here, and then once we create the subscription, then we created a resource group. Okay. So create subscription, create resource group, or you just keep accepting the default parameters. You don't need to provide anything much, but you will get, when you create a resource group, it is attached to a subscription. Okay. Once you create the resource group, then you create a namespace. Okay. So Event Hub's namespace, this is. So you can go here, you will get in this, you can search, you can say create resource, and then type Event Hub's namespace. You will get Event Hub's namespace here. So in the Event Hub's namespace, when you create, again, you are attaching it to a resource group you created and a subscription. So location and all, you can use whatever you've given. So keep consistently using the same things, same location, same region, so that you don't get cross region or cross location conflicts issues when you use this. Okay. So then you created the namespace, and then finally you create a Event Hub within this namespace. So this is here. You go to entities, and then you create a Event Hub. So there is a Starbricks demo, which is your Event Hub that you have created. Now this is all on the Azure side. So this is all Azure creation of Azure Event Hub. You have a account, subscription, namespace, resource group, and then you created a Event Hub. Now, once you create that Event Hub, you're still not there onto the Databricks yet, right? So you went here, and then you have these entities, Event Hubs. So this is the Event Hub. Once you go to Event Hub, you can see again it is attached to your subscription, your resource group, and your namespace. Okay. So here, if you go, if you go to here, namespace Event Hubs, there is a generate data. Okay, here you can select whatever Event Hub you have created, and then you can select custom payload or any of the data sets, and then these are 50 events. So if you click one time, so your 50 events are published. So you can check that. Somehow this is showing only 10, but if you go back, go to generate data, let's say weather data, you have 10 events, you publish, and you get 10 events here. Okay, so each one record is one event within that data set. So this is the source part where the Azure Event Hub is processing and publishing the events. Are we good till here? Anybody having any questions?
Yeah, good.
Okay, so basically, as I said, right, Azure Event Hub, I know we discussed last week, but still, if you want to have a recap, so Event Hub is a events processing tool, right? Event processing platform, where it has a publish subscribe model. It can publish the data, and then you can publish or you can ingest the data into this using standard Kafka logs or IoT, etc. So once the data, this Event Hub is publishing, you can read from your Databricks streaming and then process to bronze, silver, gold, and then serve using Power BI. Okay. Now, so if we have this ingestion layer here, whatever this is processing, you can directly read from Kafka also into the streaming layer. You can directly configure your streaming job or a Databricks job to read directly from Kafka. Okay. Or log files can be like on S3 or ADLS, the files are coming in. You can configure streaming. Remember, we did file streaming. So you can read it as files as stream directly into the Databricks. As and when there is a new file coming in, it can start processing. Or you can also use autoloader, which will automatically detect when the new file is coming and then process it continuously, streaming. And having event hubs will have more control of how it is collecting the data, data retention, failure on failure. How do you handle? You can go back and read from the beginning, reprocess the data. All of some extra control is provided in the event hubs. Okay, so this is what we have created right now, Event Hub. Now what we are doing in this is take sample data, publish through Event Hubs, and read through the stream. Okay, data stream here, and then see how they are processed in each of this layer. So that is the use case. Clear? Any questions?
Yes, sir. No.
Manasa? Shanmuga?
No, Arun, I am good.
Okay, nice. So what are the services required here? Is that Unity Catalog enabled, data lake storage, Azure Event Hub. That is what we have configured, Azure Event Hub. So to configure the Azure Event Hub, we had to have all that setup, right? One-time setup, like you have to have a Azure subscription, you have to have a resource group, namespace, and then Event Hub. So that is the entire sequence or hierarchy of the events that you need to set up to get to the Event Hub. Now we are going on to the Databricks side here. So you have a service, Azure Databricks, again, to configure. What it needs to process this single node compute cluster 12.2, which has Apache Spark and Scala. These are the versions. And then Maven library installed on the cluster when you create a cluster. So this is the library it is expecting to be installed on the cluster to read this Event Hub events, process scheduled from events. Now, the first part is done. We have configured the Azure Event Hub right here. So Azure Event Hub is done. Now we are going on to the next part. So again, one time you have to go here and create the Azure Databricks service. So this is the Azure Databricks service you create. Okay. And once you, so again, this is connected to, again, your resource group subscription. You can create a managed resource group, same as this. And then pricing tier, you should take premium. Okay, to process the event hubs and all of them. So once you do that, you take launch workspace, you will get to this, which is similar to what, your community edition almost. But you have more features here. You will have SQL editor, you will have workflows, you will have dashboards, queries, and then job run, data ingestion, Delta live tables. So we will explore these in the coming classes in the advanced topics. So once we wrap up the foundation thing. Got it? So this is how we create the Azure Databricks service, right? Okay. Now, you're going to compute. So basically, this is the compute. You create a compute. Just use single user, whatever is the user access, and use this 12.2 because in the notebook it is given, right? What particular version you need on this to be working with that. And use any of the standard D4 16 GB memory, whatever. Okay. And in the libraries, go here. This will not be there. Okay. So let me, you can go click install new, go to Maven, search packages, click here, use Maven Central, and then here paste this Azure Event Hub Spark _212. So you will get this, select this 2322, select, you will get the get it here, start. So that is the configuration you need to do. So then you start your cluster. So give it some time to get started. Okay, and meanwhile, we can come back to the notebooks. And then go through this. Okay, so we were talking about the connection string, right? How do we get this endpoint? Okay, so here, when you're creating the Azure, where is the that's just not true. Yeah. So if you go to the Event Hub and then go to settings, there is shared access policies. Okay. So you can go here and add a new access policy. Where's this? Not here. Start. So here you can go add a policy. Just give any name. Okay. Demo policy and just select all of manage and then say create. So once you have this, you will get your connection string. Primary key, secondary key, or something. If you copy this and come here and paste, so you will get everything until here. This complete connection string from endpoint to the Starbucks demo. So you just have to copy and paste this here, whatever shared access key that you create. And then event hub name. So whatever the event hub you have created, so that event hub name you can provide here. So this is how you create the shared access policy, and that will give you the connection string, everything. All right. Any questions? So I will just comment out this. I don't need. Oh, what happened?
Harun, you copied only the connection string which is primary, right?
Yeah, that
Okay.
is enough, good enough for us.
Okay.
We just need one thing. the primary key, secondary key. You get two keys.
Okay.
Okay, just in case as a backup, but you just need primary key. That's good enough. See, that's what I was telling you, right? As a data engineer, you will get all of these created already. You will be provided with all the connection strings, details, how to connect to a particular system. Okay. Now,
Okay.
this is the standard one. Your whatever connection string you are configured here, you just it uses this, so you don't need to change any of this. All you have to do is get this event endpoint here. Sorry, not event, endpoint. This thing key from there, and event hub name here. Okay, so that completes our setup. Now we can actually get started. Go here. So our cluster is up. I go to catalog. Okay, so here, see, is already created. Weather data, yellow taxi, all of this is here. Default, there is a gold, silver, and all of this. Okay, so you can actually drop and recreate those. If you don't have here, let me go here. So I will just run this. And if I run this, it's already exists. So you will again get the same error. So what I will do, do %SQL drop schema bronze, drop schema silver, drop schema gold. So I'm just dropping and recreating again. Oh, it contains.
Arun,
Yeah.
can't we just delete that whole cell? I mean, so that it can get deleted, right?
Sorry, come again.
You have dropped the schema bronze and all right now, as they are created previously.
Uh-huh.
So can we drop that whole cell, delete that whole cell,
This one?
so that
Okay.
it get deleted, right?
No.
The whole
Cell has nothing to do. This notebook has nothing to do with the database. See, think of it as database is permanent. Okay. Your code is temporary. Notebook. This is just a notebook that is accessing and creating those objects.
Okay.
Everybody will have different notebooks. Everybody will create their notebooks. Everybody will write their code. There is one table. 10 people can write 10 applications to access the same table. If I create this in the company, database is permanent. Once somebody creates the database, creates table, puts the data, it's permanent, it's persistent. Any application, any user who has access to those tables, he can log in and see the tables and see the data. Any other notebooks can also access that. But if you drop the object from one notebook, the other notebooks, other code, whatever, they will not be able to access. That's how you have to look at. Deleting this cell will do nothing. It's just part of this notebook only, this application only. If you want to delete in database, you have to explicitly use SQL commands to go and run on the database and drop it there.
Okay.
Okay.
Yeah.
We cannot drop schema because it has tables already in that. So either you cascade something, I think let's see if this works. So Cascade will actually go and drop the objects in the schema and then drop the schema finally. Okay. So if you go here now and refresh the catalog, so now you don't see that schema, bronze, silver, and gold. Correct? Now you go here and execute this code. This is actually going to the catalog and creating the schemas there. Now you go here and then refresh. You see those schemas created here. Right? Bronze, silver, gold, but they don't have tables yet. If you look at this, there is no data, no tables. You have Hive Metastore, you have bronze, you have no tables here yet. Now, what is the next step? Set up Azure Events Hub connection string that we have already done. Now, read and write the stream to the bronze layer. So how do you read? Spark.read stream. Format is Event Hub. So just like CSV, JSON, right? Rate, same thing. The format for this is Event Hubs. For Kafka, it is, format Kafka. So you have to give the format. So for autoloader, the format is cloud files. So each source type will have a different format.
So yes, we can call Event Hub like a Kafka. You can call this Event Hub as a Kafka. Read the log files.
No, Kafka will have format Kafka.
Okay.
If you want to read from Kafka, you should write format Kafka. If you're reading from Event Hub, you should read format Event Hub. See, basically, you should have a connector to connect to Event Hubs or Kafka to read, right? So those connectors is what we have remember when we created the cluster, we installed the library. So that library, it is used to connect to the Event Hubs using this configuration.
I'm asking is Kafka and Event Hub, both are for the log storage purpose. Is that true? Kafka is a tool for reading logs, all these kind of things.
It is. I don't say it log storage. Okay. Kafka is again an event processing. These are all event event processing tools. What do you mean by that is different systems can publish events to this tool, okay, platform, and multiple systems can read from the tool. It's like a hub and spoke model. It is a repository, central repository. It's like a water tank. People, keep putting water from multiple sources, and people from multiple sources can read. Now, when they are reading, there is a bit of control. It's not like once they publish, it is gone if you don't read, or once you read, it is deleted. It's not like that. It's not deleted. So basically, it has a structure. Anything that is published, you can configure how long you store that water in the tank. Okay. You can say, I want to, it's called retention period. You can say, I want to retain the data for 3 days or 7 days, whatever it is. And after that, those events will be deleted permanently. First thing. Second, each consumer, okay, so the systems that put data into this are called producers. They are producing the data. They are producing an event. They produce the event and write it to the event processing systems, platforms like Kafka or Event Hub. So those are producers. Now, who read the data from it are consumers. Okay. Say, for example, let's take, I have a Kafka system, okay, where it is having all the consumer tickets, customer care tickets. Okay. Now, who can write to that Kafka customer care
Call center.
based on the source? Let's say customer care agent. Somebody has called up customer care agent and he has logged in an custom case. So from the customer care agent application, an event is triggered and written to Kafka. Second, the customer has gone onto web, okay, online web, and there he has logged a ticket himself. So from the web application, the event is triggered and returned to Kafka. Third, he has opened an app in the phone and created an event ticket. That also goes to the Kafka. So there are three different sources that are writing the tickets to the Kafka system.
Okay.
These are producers. Now, you can say within the Kafka, they can write to different logs, partitions, right? That this is written from this system, this is written from this system. But topic is, what is the topic?
How many
The topic is the ticket. It's a complaint or is a issue, whatever they're logging. It's a ticket, customer care ticket. Even if it is coming from three different sources, the topic is ticket. So they can have one topic called customer care tickets. All three systems are writing to that log using the same structure, same topic. Now on the right side, who will read those tickets? Who is resolving those tickets, right? It can be a tech support, it can be business, or it can be functional users, anybody, right? So based on what ticket it is, right? So all those systems will read from those tickets and then work on it. So that is a pub sub model. So multiple users are reading, and then when multiple consumers are reading, so let's say 100 tickets, each consumer can read all the 100 tickets. If I read 50 tickets today and the other consumer has read 100 tickets, it will not mix up. When I go back, it will give me the 51st one. It knows this consumer has read these many events. Watermark, it will mark based on the consumer. The other consumer might start reading from the beginning, new consumer that is coming in. So all that control is built in. Any consumer can come in and start reading from the beginning, or he can start where he has left off. Okay. So all that is monitored. Now, if say on my end, I have kind of screwed up some data and deleted. I want to go back and read the last 1 week's data. It is possible. I just simply say reset my watermark to beginning. Then I start reading, it will give me all the 1 week's data to read. If it is retained, if the retention is 1 week. If the retention is only 3 days, you cannot go back to 1 week. You can read 3 days data. So that is how these systems are all, the PubSub systems work. It can be Kafka, it can be Event Hub, it can be MQ series. There is one RabbitMQ something. All of these are basically PubSub models. Out of which now I think is the mostly used ones, popular ones rather, are the Kafka, and here we have the Azure Event Hubs. Again, these are all compatible with each other. They can work together. It's not like either or. They can work together as well. Okay. So that is the high level understanding of how these pub subsystems or the event processing platforms work, right? Now, so that's said, right? So as I said, that format will depend on which source you are reading from. You are reading from Event Hub, you put Event Hub. If you're reading from a Kafka, you put Kafka, and then use the libraries that can connect to Kafka and read for you. Okay. And then you provide these configuration that you need to read from this. So once
In
you
real time, what are the types of formats in Azure, Kafka and Event Hubs, or any other?
real time, mostly you will have Kafka, okay, So basically, you will have files, okay, CSV and JSON. You will have all see whatever we are doing here are the most common ones in the industry. I have actually worked with CSV JSON files. I have actually worked with the Kafka. Okay, Event Hubs, I haven't actually worked, but Event Hubs is also popular. Wherever there is Azure Databricks, it comes with Azure, so it is native. So Event Hubs is also popular. But it works similar with the Kafka, similar like Kafka endpoint. So as we are showing here, right, even if it is Kafka, they can still route it to the Event Hubs. So the Kafka can also route whatever is the data coming into Kafka, they can route it to Event Hubs, so that you all other multiple sources again come to one hub, so that you don't have to read from 3 different sources here, right? So if you want to have a streaming job, right, so you don't have to read from one notebook from Kafka, one process from log, one process from IoT. You can all get different sources into one event hub, and then this can read from the event hubs. Okay, so the structure, event hubs might be different. Each event hub instance might be different. That you can just change this name. All configuration will remain same. The event hub name might be different. So just this name might be different for a different different data that is coming in. Okay. Does that answer your question?
Yes, sir.
Okay. All right. Here, since we are here, now let me go to SQL editor. So this is just like your any SQL. Okay. You can write your select statements here. Select star from bronze dot. What is the table name? And why is this so slow?
Arun, SQL editor is same like notebook only, right?
A SQL editor is same, but you can only use it to interact with the database. You cannot write Python code or whatever other code here. This is purely
Okay.
to write only SQL statements to interact with your database.
Databases. Okay. Yeah.
Okay. You can write only queries here, or create tables, just like what you are doing here. All %SQL, whatever you are doing here, you can do here.
Okay.
It is using a starter warehouse to, okay. Let this start. It's a warehouse engine to connect to the catalog. Meanwhile, we can also do from here, use this. It is, yeah, automatically it understands what we are trying to do. So powerful, the AI. Gone. So customers table is still not there. Okay. Because we have dropped all the tables and schema, right? And then we have recreated the schema, but we don't have the tables yet. So what we will do here, first we want to run the So first we will start this process here. So it will start reading the stream. What happened? Not defined. Didn't run this. Okay, let me run this. Okay. Now we have reading the stream, display, and then writing the stream. We are writing. Let me stop this. Is it created already? Okay, that's okay. We are reading from the stream, and then we are displaying the data frame here. So query returned, no results, right? Now we go here because there is no data in the stream. Now we go here and go to data preview. Hello taxi. And 1 second. Okay, so let's send this from here. Couldn't read. What happened? Oh yeah, see here. It already read the data, 50 rows that we published. Okay. Now we go back here and see. Oh my God, it's still starting. Catalog, yellow taxi. Table is created. There is no data. Okay, because we removed that stream.write, correct? So I can execute this. There is no customers. The table is yellow taxi. Okay, query return, no results. Now we go back here. We stop this. Rerun this. See, the old data is gone now because we haven't written it into the database. We stopped the entire stream. We restarted. So all that data is gone. Okay. So now if I have to again write it to the database, I have to read it again. So I go here and publish send this data. Now, when I send this data, it is published and the stream will start reading that data. Correct? Are you guys with me?
Yes,
Yes, sir.
What is happening?
You'll have to publish the data and then
Yeah. So we have to publish. When we are publishing, somebody has to keep listening that, data is coming in, process it, write it. Okay. So last time what happened? We ran it. It was listening. We published. It read the data. It displayed. Then the other part,
Did
right
not read.
part was not there. The data is still here in data frame. Now we stopped it, stopped the job, which means all the memory is gone. Data is gone. Now we restarted it with read and write. So again, it is waiting for the data to come in so that it can process and write. So what we do, we go here. So now we started this. This will continuously keep running. So normally in the production also, the streaming job, when you start it, it keeps running continuously until you go and stop it. It's like that. So it is running and waiting for the data to come in.
Means you give append means it's only reading the latest data. What is the new, not the existing.
I wouldn't say that. Append means you're writing to the table. Whatever data is coming, you are continuously appending it to the table. I'll show you what that means. Okay. Append means checkpoint is where, it will store the metadata and some forward logs. It will store how much data it has read. If it fails, where it needs to restart from. Append means in the table, you are not overwriting or you're not updating. You are just appending, adding the data to the table.
Okay.
Format, you're writing to the delta format. Table name is this, yellow taxi. Now you have seen there is no data here yet, right? So we can just execute it again and see there is no data. So there's already data here. How did this data come? It is already written.
Still showing without completion.
No, I think the previous data it has already written before we stopped it. Hello taxi data.
Data is continuously streaming and appending to the table continuously. So until you stop, it is appending, right? So the size of the machine or that one is continuously means in Azure they increase the size.
Where? In the tables?
In the tables, yeah.
Yeah. So it is continuous, right? So every day, if you get a million records get written to the database table.
One thing, Harun, normally if some million records are processing in real time, okay,
Yeah.
And you wrote the script, right? It's continuously reading the files,
Yeah.
okay, from Event Hub,
Yeah.
okay. It's suppose it's continuously means it's is there any buffer time or it's ongoing just without any gap?
No, there is no buffer. So normally streaming, you have options. How many seconds you want to read. So you can trigger window is there. All those options will show. I mean, we are just starting here. There are some options. It will tell you, should you just trigger and read once or it is continuous. And then there is another option. When do you want to read? Every 5 seconds, every 1 second, or every 1 minute? You can also configure that. The job will be running, but it will only go and read every 1 minute or every 5 minutes and then get the data that has been there in the last 5 minutes. That is where it will store that checkpoint, right? It will know how much data it has read from where it has to read from every time. There is also something called windows, overlapping windows and sliding windows that within the stream you can maintain. If you're not writing to the table immediately, how much data I want to maintain within my memory. 1 minute or 5 minutes sliding window. So every 5 minutes, you can go and read the data for last 10 minutes. Okay. So every 1 hour, so or every 10 minutes, you refresh the last 1 hour's data. It's a sliding window.
Mhm.
Okay. It's not like at 1 o'clock, you read data from 12:30 to 1. Okay. Now at 1:10, the window, sliding windows 10 minutes, you still read 30 minutes. So what data you will read? You will read from 12:40 to 1:10.
Mhm.
Okay. At 1:20, you will read from 12:50 to 1:20. So the window keeps sliding forward. The
Mhm.
previous data keeps going out. If you want to see, say, performance logs, right? How or CPU usage, if you see, CPU usage will be continuously showing. The older data will be going away, but you still see last 1 hour's data anytime. Right? So that is how you can configure what is your sliding window, what is your interval. So all those options are available when you're reading. Okay. But here, as of now, it's continuously reading. I haven't given any time. So every as and when, like micro batches, every 1 second or so, it keeps running. Let me go here and say truncate table bronze dot yellow taxi. Okay, that is done. Okay, now there is no data. I have deleted all the data, fresh. Okay, and see the stream is still running. Okay, now I go here and I'm publishing 50 events. Completed sending events. Now I come back here. It should start reading those events. 50 events, not doing anything. See, automatically it has read 50 rows. Okay. 50 rows it has read. Now I go back and check in the database table, bronze.yellow taxi. See, you have 50 rows. That's it. You only have 50 rows. You can keep refreshing, querying. It will not change because there is no new data coming. All it has is we published 50 rows, it processed 50 rows, it has written to the database, and then it's still waiting for the new data to come. It's still polling, it's still running, right? It's still looking for the new data. There's still no new data. There's only 50 rows here. There's no new data. And in the table also, there is no new data, only 50 rows. We go, this is sample data. Let's go to SQL editor and see if this is up. Nice. It's okay. It's not working for some reason. It's not coming up, but you can still see here bronze, yellow taxi, sample data you can see, but see, you have only 50 rows. It's the same thing. I mean, you can do Spark SQL here, SQL, get data from here, or you can go and Catalog Explorer also, you can go and check the data. All right, so 50 rows, all good, right? Right?
Yes, sir.
Everybody with me? Okay. Now I go here, go to data preview. And go here and publish the data again. 50 rows. What happens?
We'll probably get another 50 rows due to append mode.
Correct. So because we are appending the data, we will get another 50. So go here. Now it will start reading more data. Another 50 it should start reading. See now 100 rows. Okay. Now I go here, run select star from bronze, 100 rows. Got it? So if I publish again, it keeps adding, reading that data and putting it. That's how it is processed. Now, the same thing, let's stop this. Yes. We have cancelled. Now let's change the method to overwrite. W small or capital? Anybody?
Will overwrite the data. Like
Yeah.
it updates the data.
No, it's not update.
Right, completely overwrites it.
Yeah, completely. It's basically same thing as, you know, what we are doing here. Truncate and then load. So first let me truncate this table. We'll refresh data back so that there is no data here. And then we will start the job again. Okay, there is no data now. Select star, no results. Now we go here, run this. Append unknown output mode override. So, okay, in the stream you cannot do. You can do update and complete. Because in the batch you can do overwrite, but in the streaming you cannot do overwrite. You have to use one of these three modes: update, append, or complete. When you do update, again you have to give the keys on what keys it has to update.
This is only in batch, right? Not in streaming.
This is streaming. Streaming you do this. Overwrite is not available in streaming.
Yeah, that is I'm asking. Okay.
Yeah. Okay. We can explore this modes later. So that is the overall crux, how to read the stream. Rest all is same, right? So once you read the stream, then you process that. Okay. Let's go back here. Start the stream. This is the JSON schema that we have created. Now, read stream format delta. Okay. So the first part you see here, in a standard any pipeline, the bronze, whatever you read from event hubs or whatever streaming, you write to bronze. Once you write to bronze, this is a delta lake, right? Delta table. Now you are reading from this delta table, processing it and writing to this silver layer here. Correct? So what is the source here when you're reading for silver? Read and writing the stream to bronze layer. We read from event hub and we are writing. Now here, defining the schema, we defined the schema. And then here we are reading the stream. So read and transform. Load streaming data from bronze.weather. Okay, I think this is weather data that they are writing here. No, this is yellow taxi. How come they can weather table? They can. They kind of mixed this up. They are reading weather data, writing the yellow taxi data. Okay. We'll have to use it if this is weather, this is, how come they use
Oh,
this?
they're reading the yellow taxi only, Harun, I guess, in the.
Yeah, they are reading yellow taxi. This is also yellow taxi. But these, oh, okay, body, okay, this is a drop off, okay, yellow taxi only. Yellow taxi, no, they see here it says weather. And it should be yellow taxi. And just the comments are off, I think. There's another notebook for weather data. Probably, yeah, we can check. You guys can try with other data sets as a practice. Okay, now from the bronze yellow taxi table, we are reading. So we are read stream. Now format is delta, because from format event hub, we processed and wrote to bronze layer. That is a delta table. Now format delta dot table bronze dot yellow taxi, right? And then we are processing it with column body dot cast as string. So we are converting the encrypted data to a string. Why we are doing this? If you see here, we don't have, where is that data? Do we have data? Okay. Let me run once. Okay, this is still not refreshed. So if you see here, this is all, it doesn't make sense, right? This is all encrypted data. Okay, it only gives you partition, offset, sequence number, enqueue time, publisher, system properties, all of this data. The entire actual data that is sent is all in this column. This is something that you have to see, body. So all the data is in the body column. Everything, whatever you have published from here, all of this entire thing goes into one column here, which is called body, which is in encrypted. And this is all metadata, which partition it is, what is the offset number that you are reading. As I was saying, right? If you want to reset the offset, you can reset this and go back and read, the earlier records again, if you want to, watermark. What is the time it was enqueued, who was the publisher, all this, mostly metadata thing. The actual data is in this column called body. This is encrypted. Now what we are doing here, we are casting it to a string. We are converting the body into a string. Once we convert it into string, it's in the JSON format. We are mapping with the JSON schema. Take that string and then map to this schema, right? So this is the schema we have here: vendor ID, location, start, end, last, rate code, tip amount, total amount. That is the schema we are parsing. Convert this part. This is a transformation, right? Silver, you do transformations and write to silver. So take this data from here, convert it into a string, which will automatically decrypt. Once the string is there, the string will be in the JSON format. It will come back in this format. Now we have already done how to process the JSON format, right? So what we will do from JSON, this column with just JSON schema. Again, using the same column. You can also use different column names. This you can say body JSON, and after reset body final. It's okay, and just leave it as body, because all of this we have to change them. Okay, we are converting into a string and calling it body underscore JSON. I'll just say body underscore str, which is a string. Now it is in the JSON format. We are using the JSON schema that we are provided and converting into a body in the JSON format, and then reading each column from there with values. And then if you want to change alias enqueue time, we are converting it to timestamp column name, renaming the column. Visualize the transformed data and then writing it to the append mode again into the delta silver.lo tax. You guys are with me?
Yeah. You're reading from the bronze schema and writing into the silver schema. Okay.
Yes.
But the question is, that's why this is the normally just one delta file, right? Means you're saying this file is going to be appended always, means it's data to be appended to this file, okay, every 10 seconds or 10 minutes. That's why you're giving that the stream as option here.
Yeah, whenever there is a new data published, right, it will come into the Event Hub. So Event Hub will publish. You will read it, write it to bronze, and then read from the bronze, write it, transform it and write it to silver, read it from silver, generate the aggregation, and then write it to gold. This entire pipeline is streaming pipeline.
Okay.
As soon as you get a new record in the source at the top from Event Hub,
Okay.
it has to reflect all the way in your gold.
Okay.
So it is passing through all this pipeline, right? So as soon as you get, say, 50 records here, that should reflect here in the gold so that I can see that in the Power BI dashboard.
Okay.
That is the entire pipeline process, right? Otherwise, if we just keep writing here, what is the purpose?
Yeah. Means from
Streaming.
there to silver to gold. And
Yes. Okay. Any questions? Now, this is the silver that we are writing. So this is not there. This is, I think, old data. We'll remove this.
Harun,
Now,
just a small question out of curiosity.
no, yeah, please.
So the every event that is published, each event, it goes into bronze, and then we stream it to silver and then gold, right?
Yes.
And so each event goes to silver, bronze, and gold, and then comes the second event to the bronze, or all the events are streamed to the bronze, and then we'll
Batch,
send.
right? So whatever streaming is also a batch. It might be a micro batch. Every 1 second, if you get 50, all 50 get in one batch. All 50 get to silver. All 50 get to gold.
Okay.
Whenever it is going and reading, whatever is the available data, it will pick up. If the data is not arrived, then the next time when it comes, it will read.
Okay.
That is why we have all that windowing. So this is here. If you go to gold, again, we are reading from this time silver. Okay. Now see, with watermark, TPEP pickup date time 5 minutes, group by window, pickup date time 5 minutes. Okay.
Understood. Whatever the data that's
Average trip distance. What is the average? What is the average amount? Okay. So what are we doing here? We are reading the data from silver. We are aggregating for 5 minutes. Every 5 minutes, what is the average trip distance of all the taxis in the last 5 minutes? What is the average distance? What is the amount for last 5 minutes? Okay. And then we are displaying window start, window end, distance and amount. So we have every 5 minutes. See, from 12:30 to 12:35, what is the average distance? What is the amount? Okay. So like that, every 5 minutes window, we are aggregating this data.
Yeah.
And then we are again appending it to the delta. I think Subbu, you need to
ఇంకా
mute.
ఇంకా ఉంటావా?
Subbu,
వచ్చేస్తావా?
Subbu, you need to mute.
ఇంకా ఉంటావా?
Okay, let me mute him. Okay. All right. Okay. So every 5 minutes, we are aggregating the data and then appending to the gold table. This is the end to end. Okay. Now we will go. We'll start all the streams now. We don't have any data in bronze. So this stream is still running, but we don't have data. We will define JSON schema. We will run silver. That is also running. No data. Uh-oh. Unexpected delta table. What happened? Query checkpoint to restart from scratch. Or we have to restart the checkpoint. I'll just use this one. See new. We'll just use a new checkpoint. Let's see. Okay. So we redefined that, and then we redefined the code. So now all three streams are running and there is no data at all in any of the tables, any of the streams, correct? If you refresh here, I think this should go away. Okay, no data here. You go to silver, yellow taxi, sample data, there is no data. If you go to gold, trip summary, sample data, no data. Okay. All the pipelines are running. Now assume the data starts coming in. So I send 50 events. Now I come here, it starts reading from the bronze first. Okay, data is in the bronze. As soon as data is in the bronze, silver should start reading it automatically and process 50 rows. As soon as data is there in the silver, the gold will start reading from that table, and then it should display the aggregates. Come on. Yes. See, now the data is here, aggregated data. Now, if you go and check bronze, yellow taxi, sample data, refresh, bronze. Yeah, yellow taxi, see the data is there. You go to silver, yellow taxi, data is there. Go to gold, trip summary, sample data, data is there. Okay. Now here we have 50 rows, right? Now if new data comes in, it will start processing the new data again. So let's say I just want to send 2 records now. Read only. I cannot. Okay. We cannot edit this. That's fine. I think a standard data set. Now, if I send again 50, all the tables will get refreshed, added 50 more rows. We should start seeing 100 rows. Here, 100 rows. Silver, 100 rows. Processed. What about gold? Gold will remain 50 rows. Because, now why? Because you are again aggregating based on the same timestamps. Okay, here. I can go and check all the data. Get 50 rows here. Should get 100 rows here, sample data. Yeah. All right. Okay, so that is our streaming example. I'm going to stop. I will give you this, post the video. I will post also the notebook. So you can configure and run the streaming examples. Now, before we move on to start, some introduction about the certification and all of that, if you have any questions, please. Srini, are you good?
Yeah, Arun, I'm good. Just who I need to practice.
Yeah.
I understand the concepts today completely.
Yeah. Okay. Great, guys. All right. So let's stop this here and then move on to the document, right? So that Srini has posted, Srinivas Vemula. Have you guys looked at it? It's mostly, the concepts you have to go through, understand. and read through it. What are the concepts? I can go through, but it's kind of, reading together in the classroom. What are the components of Databricks architecture, control plane? These kind of, the multiple choice questions you get in the certification, data engineer associate certification you want to write. So you practice whatever we have done in the class and then read this document multiple times. Then I will send you when you are ready for certification, when you have, booked the time. Just let me know. I'll send you some videos, 2 or 3 videos. It's just there on the YouTube only. So go through those videos. That will help you in clearing the certification. But before watching those videos, you have to go through all of this document. Okay. So what is a cluster? We have configured the clusters, right? Computation for computation resources. There are different types of clusters again. You have a driver node and you have worker nodes in a cluster. That will give you in the Spark architecture that when we talk about advanced topics, how the architecture, what is a driver, what is a worker, how does the job run, how is the distributed computing done. So we have been running all the data frames, but we have not touched upon how it is processed. I mean, what is the difference in Java or in Python versus a data frame? How is the data processed? How are we getting the parallel processing or distributed computing when we use Apache Spark and Databricks, the clusters? That we haven't touched upon yet, but we will in the advanced topics. How the data is distributed on the nodes, how the execution happens on various nodes, kind of. So what are the executor cores, memory, and all of this. So read this. There are again cluster types. I don't see much value in reading this together, but I would rather ask you to go through this and then discuss. We have a class. You can take each topic and then explain any of from this. That would be better, I think. What do you think? What do you guys think? Somebody can take the topic of cluster and then just talk about these 4, 5 questions here. What are the cluster types? Cluster configuration. You don't have to remember all of this, but at least high level, if you understand, that should be good. What is auto scaling mean? Cluster size and auto scaling. So auto scaling means if you have the number of workers, based on the workload, it can automatically add new workers. If you have a huge data set, it can automatically add workers. So that is auto scaling. You can define what is the maximum limit for the minimum and maximum number of workers it can add with the auto scaling. See, Databricks chooses the appropriate number of workers required to run your job. It does it based on the complexity of the volume of data and the complexity of your transformations. How you have multiple joins or complex joins, huge data sets. Based on that, it will choose the number of workers. This is called auto scaling. Without auto scaling, dynamically reallocates workers to account, which means that whatever workers you have, it will use those workers only fixed to run the job. So what are the advantages? Local disk encryption. Have we done I think we haven't done the joins and shuffle and all of that, right?
Got it.
Yeah, not in Subbu, you know, you have already done that.
Yeah. I know.
Yeah, we have not done in this batch, yes. So some of those topics you will get once we cover that joins and shuffling and all of that. But whatever we have covered, just go through that and then we will discuss this in the next class. Is that a good approach? What do you think?
Yeah.
So you guys can choose a topic and let me know in this document itself what you want to talk about. You don't have to do the entire thing. Okay. See what is Databricks utilities directories. This we have already done, right? DB utils fs ls display to have display this. Git versioning, you don't need to do this. CI/CD, we can do that later. That also can know. Delta Lake we have done, right? Have we done the transaction logs and time travel and all of that?
Yes,
Yeah,
sir.
time travel is yes, done.
Yes, Vikas, Srinivas Shakamuri.
So I didn't remember exactly that time
Okay.
travel.
Optimize, vacuum. I think Srini has covered some of them. But transaction logs, how is it? How is the data whenever we do ACID transactions, like update, insert, if you want to roll back a table to a previous version, have we done that? Manasa, do you remember? Vikas?
Yes, Arun, we have done that. We-
Yeah, sorry, I didn't hear you. Manasa, you were saying something?
No, Harun, sorry.
Oh, what you don't know whether we have done or
Sorry, could you please come again with the question?
so I was asking, have we done the transaction log, delta transaction log, versioning, time travel, rollback transactions? Ask Shanmuga. You guys
Yes, sir.
remember?
We have done it. Yeah.
Yeah. Okay. Yeah. So same thing here. ACID transactions, each transaction, how we do metadata, data versioning, and time travel. See, this is the ACID transactions to object storage. This is a catalog. What is a metastore? Unity catalog. What is Delta Lake table? So this we have not covered yet. Delta Live tables. CI/CD Delta Live tables we have not covered. But whatever topics we have covered till now, you guys can just go through it and then get back to me on in the next class. We can have a separate class to discuss this. What do you think? But I need your participation. It doesn't help if I again read through this.
Okay.
Okay.
Sure.
Yeah. Take some topic and then just try to talk about it, explain it here. And ping me which topic you want to, or just have a Google Doc, share with others that within the group. Everybody can sign up one topic there. So that not everybody don't do the same topic. So this we can do once, and then we also can and also sign up for a demo. Any data set you take, streaming, or see, so now I have done with Yellow Taxi, right? Same thing you can try with weather data and try to give a demo, streaming demo with Event Hubs once you set up. Something like that. Only if you do the demos, if you talk about it, you will know. Otherwise, it is difficult to understand, get at the pace, because we have to go to certification, and then when you go to market, you have to attend interviews. So only if you keep talking about these concepts, practice, only then you'll be comfortable. Okay. All right. Are you guys with me? Any other questions? I think we'll wrap up. This weekend is a long weekend. I guess mostly we will not have classes this weekend.
Yeah, better. Yes, we can skip this week due to long weekend.
Yeah, normally, I mean, the practice that we don't schedule classes on long weekends. So we will come back after that next weekend. By that time, I want you guys to be ready to talk about topics and give a demo. So somebody take the lead, create a Google Doc, share with all the people here, and sign up. We will connect offline in the chat on the Google Doc, and I will see who was signed up for what. Okay? Sounds good?
Yes, sir.
Okay. All right, guys. Thank you so much. Appreciate your taking time, but need a lot of practice. We will connect offline. Have a good long weekend. We will meet the week after. But yeah, we will continue talking offline on the chat. Okay?
1 second, Harun. I'm really sorry.
Yeah.
I'm in my college library, and a library assistant came for some inquiry, so I couldn't answer your question.
No, that's fine. That's totally fine. No worries. Absolutely.
So sorry.
Yeah, no worries. All right, guys. Have a nice weekend. Take care. We'll chat often. Bye.
Thank you.